Good morning, good afternoon, good evening, everyone, wherever you are watching this from. So my name is Macharia. I'm a cloud engineer and also a Microsoft Cloud student ambassador. So this session is brought to you courtesy of the Cyber Back to School organizing team, as well as the support of the Microsoft Cloud student ambassador program. So my session is going to focus on the GitHub Advanced Security. And my title for the session is that push secure or just fast? So if you have any question, feel free to reach out to me on X at Engineer Sam, also on LinkedIn at Samuel Macharia. And at the tail end of this session, I'm going to do a deep dive on a challenge that was posed early last month, but one I guess around May, on security challenge by GitHub. So thank you, and let's dive straight to the meat of the matter. So circling back to the title of the session, is that push secure or just fast? So the focus of my session is on GitHub as a platform. And I realize that we often celebrate velocity in DevOps, but rarely do we stop to ask whether the code we are pushing is truly safe. So this presentation sets up the tension between speed and security. So the central question we'll explore is simple but critical. When you push code, are you pushing secure changes or just pushing fast? So this is basically the agenda of the session. I've broken it down into different pillars, into basically around 7 pillars. So the first block is going to focus on the velocity paradox. Then the second one is going to focus on the GHAS, that is a GitHub Advanced Security. Then the third is going to focus on automated code scanning for the secret detection, then dependency review, then real-world application. Then lastly, I'm going to pose some few key takeaways and the next steps as we dive into the demo. So starting with the first pillar, which is focusing on the velocity paradox. You see, teams are pressured to deliver features quickly, often skipping thorough security checks. So this creates a velocity paradox, and faster pipelines can mean riskier code. So as one leader described, we were building a skyscraper on a cracked foundation. So speed without security creates invisible debt that grows over time, and that is not what organizations want. Uh, Moving on to the second pillar, which is focusing on the GitHub Advanced Security, your silent sentinels, and it brings forward 3 pillars. One being code scanning, second being secret detection, then thirdly being a dependency review. So the first one, it's about the GitHub Advanced Security being a suite of tools basically designed to build security into your CI/CD without slowing teams down. So the first one is code scanning, which is basically about vulnerability detection in your code base, and which is usually automated. Then there is also secret detection. So this is about your credentials being exposed as you push code to your repository on GitHub. So this one is meant to prevent that from happening. Then there's also dependency review. So it's basically about identifying dependencies and specifically for open source repositories, you can be able to identify and mitigate risks that might be posed to your project or code. So you see, GitHub Advanced Security becomes part of the workflow and not an obstacle. So the platform focuses on these three critical areas, that is the automated code scanning, secret detection, and dependency review, each addressing common sources of risks, as I have highlighted. Then there is also automated code scanning now as a pillar, which is basically about catching bugs before they merge. So what is automated code scanning about? So it's about detecting vulnerabilities and coding errors before code is merged, which provides developers with instant and also actionable feedback. So you see, with support for multiple languages and customizable rule sets, scanning empowers developers to be the first line of defense, and it's commonly referred to as shifting security left into daily work. So for those of us who are into DevOps practices, we refer it to as shifting left for developers to be able to defend their code base by making sure that they don't push these vulnerabilities into the code base. Then the next focus is on secret detection. It's about identifying exposed credentials and rogue keys. So secrets like API keys, passwords, and encryption keys are often committed by accident. So once exposed, they can lead to immediate system compromise. So secret scanning provides real-time alerts for new exposures and historical scans to find past mistakes, which helps organizations to avoid damaging breaches. So feel free to also take a screenshot of the presentation that I'm sharing, and also I'm going to share it to the Cyber Back to School team to share with the viewers of the session. Then there is also the bit about dependency review, focusing on how to unmask risks that are hidden. So you see, modern applications rely heavily on open source libraries, which can bring hidden vulnerabilities into production if not carefully reviewed. So dependency review identifies new or risky packages before merging, equipping developers with the context needed to make informed security choices. Then I thought of adding a case study, basically to elevate a client security posture. So one client's pipelines were fast but insecure, plagued by exposed secrets and outdated dependencies. So manual reviews slowed teams and left gaps. So after adopting GitHub Advanced Security and training developers, the client reduced critical security findings by 80% and shifted to a proactive security culture. Then some key takeaways from the theoretical part of the demonstration, I mean the presentation, it's on how to ship fast and ship safely. You see, security must be treated as a feature, automated wherever possible, and owned by developers at every stage of the pipeline. The real goal is not speed alone, but secure speed. shipping faster while protecting systems, data, and customer trust. So you see, the next step for most organizations is on how to adapt the GitHub Advanced Security, and starting small by evaluating GitHub Advanced Security in a pilot project, then expand gradually across your organization's repositories. So provide training, monitor progress, and remember the ultimate goal: shipping not just code, but secure, reliable, and trustworthy code. So we are going to shift gears and dive deep into the technical demo. So allow me to share my screen again. I want to share this window. So yeah, so this is one of the challenges that was posed by the GitHub team. May is usually the maintenance month for security open source projects. I got a chance to participate in the challenge. So the challenge was focusing on these the three GitHub skills. So the first one being introduction to repository management. The second one being how to secure your repositories, a supply chain. So this one focuses on proper dependency management. Then the last one was focusing on introduction to secret scanning and how you get to secure your repositories. So I guess we have enough time to basically go through the last one. We can start with this one. I want to make sure that this is still recording. Nice, nice. So this was a challenge brought to you courtesy of the GitHub team. So the first step was for one to copy the exercise to your account. They just need to do so. So maybe you can try creating another one, change the repository name, then create a repository. Since I already done the challenge, then maybe probably I can also drop the link to the challenge in the chat section so that you can also have access to it and try it out. The best way of learning most of these things is doing a demo. Yes, so there's the link. So basically, if you go to https://maintainermonth.github.com/security dash challenge, then you have access to the challenge. So this is the challenge. I now have access to the introduction to secret scanning. So what else do I need? So in this course, you'll get to learn how to enable secret protection, identify secrets stored in your repository, then enable push protection, then stop secrets from being written in your to your repository. So I guess I have to refresh my repository again. And yes, so this is the repo. So I need just basically to start the exercise. So go to the exercise. Then this is usually automatically automarked. Just need to follow the instructions. So step one, I need to enable a secret protection. So and how do I do that? So I need to follow these steps. So let me scroll through the instructions. So in the header of your repository, open settings in a new browser tab. So I need to open settings in my new browser tab. There you go. Yes, I've just opened settings in a new browser tab. Then after that, in the left navigation under the security section, select advanced security. Security section, I need to select advanced security. It's right here under the security section. Then after that, scroll down past the code scanning and dependable sections until you find the secret protection section. Scroll down the code scanning and dependable section, then adjust the default configuration to match the below. So for the secret protection, I need to make sure that it's enabled, then push protection is disabled. So I need to do exactly that. Go to the secret protection section and enable it. So I need to enable this one. Repository settings saved. Disable, enable. Let's confirm that again. Disable, enable, right? So it should be secret protection enabled. So it should be vice versa. So I need to disable secret protection so that we can also see how it works. Then I need to let me refresh this tab. Let's first enable it so that we can. Yes, so it needs to be. You need to disable push protection, then enable secret protection. So this one should be disabled. Then I need to enable this one. I mean disable so that we can see. So yes, so we are good up to that point. So the next activity is to commit a sensitive file. So in the header of your repository, I click the code tab. So I need to click the code tab in the head of my repository. I come right here. Then above the list of files, click the add button, drop down and select create new file. Then enter the file name as credentials.yaml. I need to copy the name of this file and copy the following inactive example credentials into it. So I need to create a new file right here, create new file. Then the name of the file should be credentials.yaml. Then after that, I need to copy this inactive example credentials into it. Copy that, and you see these credentials have AWS access key as well as the access key ID. So as you can see, it also has a MongoDB name as well as the password. So which are very sensitive credentials for a user, and they should not be exposed in a repository. So our goal here is to get to see at the response from GitHub, getting the secret scanning alert. Then after that, in the top right, use the commit changes button to commit directly to the main branch. So we just need to use the commit button to commit our changes. And then create credentials.yaml. Yes, you can go with that. Or maybe you can confirm the next step. With our credentials file accidentally shared, Mona should quickly notice it and prepare the next step. So I need just to commit the changes. So let's wait to see. So yeah, so Mona has noticed that we have made changes and we have committed a file that has secret credentials. So we go to the next step, which is basically about review and close secret scanning alerts. So in the header of our repository, we click the security tab. You go back to the security tab in our repository. Then in the left navigation, select the secret scanning option. Secret scanning option. And you can see from this point, we have three tools that we can use to ensure that our repository is always secured. So first we have Dependabot, which ensures that dependencies that are outdated, they are always flagged. Then there's also code scanning for ensuring that our code doesn't have vulnerabilities. Then there's also code scanning for ensuring that our secrets to our accounts are not, I mean the credentials, they are not pushed to our repository. So we go to secret scanning. When you move to the next step, notice various options in the header bar that can help triage our alerts. Click the provided drop-down and select Amazon AWS to filter the view. Notice only 2 of the 3 entries are listed now. So I need to go look under the secret scanning alerts. So it's disabled. I need to enable it. Enable it. So then I go back to the security tab, and you can see already we have 3 secret scanning alerts. Exactly. So as you can see from the file that we pushed, these 3 credentials have already been flagged. That is the Amazon AWS Access Key ID, the MongoDB Atlas credentials, as well as the Amazon AWS Secret Access Key, which has been done using the secret scanning tool. So then for the next step, you notice various options in the header that can help triage our alerts. So click the provided drop down and select Amazon AWS to filter the view, and notice only 2 of the 3 entries are listed now. So I need to filter this. So let's see what they say about filtering, and select provided drop down, select. So provided drop down, yes, here it is. Then select Amazon AWS. Then we are left with the Amazon AWS for the access key, and as well as the secret access key. So activity, the next we need to review a secret scanning alert. So in the list of open alerts, select the Amazon AWS access key ID alert. So we are right here. So at the top of the page, we can quickly view the alert status when it was opened, the exposed secret, and some remediation steps. So if you open one of the alerts, for example, this one for the access key ID, this is what we will see. We have the remediation steps, or steps that will help us to resolve the issue, and also the detected locations for the secret key. Then when you scroll down slightly to the detected in X locations area, you will see all the places where the secret was detected, including the credentials .yaml file that we created. So let's move downwards. So the next activity is about closing an alert. So assuming you have taken the remediation steps, we can now update the status of our alert. So in the top right, select the close as drop down. In the top right, close as. Then after that, choose the revoked option and enter a useful description of your remediation steps in the comment box. So for this, then choose close alert. So we need to use this description for remediation step, which basically says the secret owner was contacted and they provided proof that the exposed secret was replaced. So we are assuming this is a developer who is trying to resolve an issue, and you need to close the alert. So I just need to go to the revoked option. Then I enter the description of the comment, then close the alert. So, and you can also reopen the alert in case it was not resolved. Then I scroll downwards. So the alert status now displays closed, and the audit trail includes our explanation. So we can also confirm whether it has been closed. Yes, it has already been closed. So then with at least one of our alerts resolved, let's add a comment to inform Mona that we are done with this step so she can share the next one. So once I've done so, I need to come back here. So I need to inform Mona that I'm done with that